Hi everybody. So it will be a bit more than just that, but it doesn't matter. So I usually walk around a lot. Being an Italian, I gesticulate a lot, so I see that I have limited space here. I'll try to make it work. So I'm Giovanni Lanzani, as Tunde said. If you want to write a live or a batch snarky remark at me, that's my Twitter handle down there. My wife always appreciates when somebody does not agree with me, because that means she's not the only one. Who am I? Imported from Italy in 2006 by my wife. Before it was cool moving outside of Italy. I somehow got a master and PhD in theoretical physics in Leiden. And after that, I was a PowerPoint monkey at KPMG as a software quality consultant. And then 3 years as data whisperer at Data Driven, and now since like a year I'm chief science officer and senior shoe designer there. That means that if you come work for us, I'll design a pair of Nikes for you. And as probably Niels already said, we're hiring. I was the chair of PyData Amsterdam last year, and now not anymore. And the reason is in the last bullet point. I'm father of 5. That means I'm pretty busy usually. And I'm the co-organizer of the PyData meetup with a lot of fine folks here in the audience. So what I'm going to talk about? Oh, I have like a convention. If you need to ask a question, this is the hand sign you have to make. I usually try to stop. So data scientists in 2012 already, so 4.5 years ago, they wrote this article that kind of went viral. The sexiest job of the 21st century. And of course, a lot of companies wanted to do data science from that moment. And I don't know about you, but a lot of companies that do data science, they want to do machine learning. And of course, the first question is, what is really machine learning? And in essence, machine learning is learning from data. Yeah. So you have a lot of data, maybe not so much, and you want to generalize. So like the yellow points are the data points you're getting, and you want to find the blue line. And of course, you have lots of possible options. And as you can see here, you could choose like the blue line, which is okay, but it doesn't really capture the richness of the underlying data. You could choose the green line, which is better, or the red line, which seems, I mean, if you know a bit of machine learning, it's wildly overfitting. And the thing is that a lot of companies forget is that 100% correct answers might not exist. And maybe the 100% correct answer is not what you want. Probably many of you know Amazon.com and the shopping experience that you have, that like at the end of the page or somewhere in the middle, I don't know, they say other customers also bought these items. And what some people do not know is that Amazon is not using the best algorithm they can use, because people were freaked out by how good Amazon recommendations were. So of course they A/B tested like they do with everything, and people really didn't like the better algorithm. They want something, they wanted something worse, but that didn't scare users. So even though you can actually get the green line here, maybe you really want the blue line, and it has nothing to do with science. It's all to do with business. So a good PO, a good product owner, needs to actually find the line that is the best trade-off between these two tensions. Now, what machine learning can do, of course, it can do everything: supervised, unsupervised, reinforcement learning. And the next question is then, what's data science? And of course, for me, going to a lot of companies, data science, it's about creating value using data. And you may use machine learning, you may use visualization or analytics. It can be done with Excel or whatever you want, but it needs to create value. So if you have just a dashboard or a report on your laptop or whatever, and nobody's using it, even though it tells the truth, it's not really helpful. And then, of course, this is what we say, and then when you go to companies, and you say data science, and they want to do all the things with big data, and predictive modeling, advanced analytics, all the buzzwords that they hear about. They want to make more money, and all the other things the others are doing. Who these others are, they never know, but there are others that are doing cool things with data science. They want to do that as well. So how they try to get there? So first of all, you need to go beyond the data warehouse. So usually in the traditional data or BI world, you would have this traditional data, operational data sources in your company. And then it was the job of some DBA to actually import them into the enterprise data warehouse. Somebody would sit down behind the laptop, write a query, and once you write a query, all the dependencies for your query are contained into the enterprise data warehouse. So in principle, what you just wrote can instantly go live. And it can power your traditional business app, your web app, your dashboards, reporting, instantly. Because everything is there. But now people want to do more, and they want to add unstructured data, they want to add logs, chats, transcripts, they want to scrape external website, they want to use an API, and of course SQL is very boring, so they want to use machine learning, and now they have this problem of data pipelines, because the first thing you see here is that the typical DBA, and I don't want to offend anybody, but it cannot really build these pipelines between all the new kind of data that you want to use in your model into this data platform. And then you need people that think about the appropriate storage, because not everything can be contained in SQL. And then you want to scale. So the promise of all these new frameworks and everything is that you can scale very cheaply. Because of course, SAP and Oracle can also scale if you have all the money in the world, but that's not what most companies have. And this landscape contains way more challenges than you may think of because of all this new tooling that you're using. So a lot of clients we have, they use Spark. And why they use Spark? Even though they don't have big data? Somebody wants to take a guess? Because it's cool, it's fancy. The others do it. Very good. Well, in principle, they say, if I use Spark, even though I have little data now, I won't have to change my code when I will get big. So I have a simple framework to rule them all. So I was, a couple of weeks ago, I was an energy company here in the Netherlands, and they had this very cool Spark pipeline to basically determine the, well, you can imagine they were determining the customers that were going to churn. And they were very happy. They had like 9 months of work. And then somehow they found that the random forest they were using was not very good. So from a level 10 random forest in Spark, they went to a level 15. And then the running time of the whole pipeline shoot up by a factor of 10. So they were, I don't know, like they needed 2 hours before, and now they were needing like 20 hours to finish the pipeline. And they said 20 hours is too much time. We are not getting money out of it yet, but our Amazon bills were just like, they went through the roof. But the model was very good. And basically they had no idea how to fix it. So they looked at the code, they looked at the Spark UI, and they were observing very high garbage collection times. And what do you do when you see that you have high garbage collector time in your Spark application? Stack Overflow. But they couldn't find the answer on Stack Overflow nor Google, so they called us and I said, please can you come and take a look? And of course I didn't know the answer when I came in, but I think I can use Google better than they can. But it's also that I know a bit more of about Spark that they knew. So it turns out that, well, of course you have a random forest. So when you go to 10, the depth of the trees goes from 10 to 15. You get 2 to the 5th larger models. That means that their models that were serializing on disk went from 30 megabytes to 250 megabytes on disk, and they were trying to make the thing faster by adding more partitions. Because of course in Spark they say, well, more partitions is usually good, which is most of the time is true. But and they just had like 4 or 5 executors, I don't remember, pretty large executors. The thing is, every partition in Spark will load the model from disk every time. So if you have 1,000 partitions and like 3 executors, you will see that each of those partitions will start reading the model from disk. So they were not only getting huge garbage collection times, they were getting the task deserialization time was 10 times as that. And of course, once you know it, it's easy. But to get there, it was a real challenge. So a lot of companies, they know how to do Spark because they either read the book by Holden or they read it in a blog post and they can immediately start doing things with Spark, and it seems like the same thing as with Python, but then using another framework. But down there are so many challenges that are just waiting for you to really use it with big data and in real models to blow up in your face. So what companies got, a lot of proof of concepts, a lot of screenshots, presentations, and dashboards that work on your laptop with like 200 kilobytes of data. Extra mouths to feed with no really additional return because you got a whole department doing big data now. And then, of course, a lot of nice stories to tell to their network, to their peers about those screenshots, but especially about those dashboards. And then, of course, all their data and infrastructure is even more scattered than before, because before they were just having this operational data sources and the enterprise data warehouse, and now they have like Neil said, they have Spark and they have Hadoop and they have a cluster of Zookeeper instances to keep in sync, and they have this and that. I mean, I don't even want to talk about Kubernetes, which is a great thing, but when you're running it yourself, there's a lot of challenges. And of course, you got to talk to them. And they say, well, we have data scientists, he's working on trees and forests and neural networks and deep learning. And I follow the Twitter feed of PyData Amsterdam these 2 days. So they can tell cats and dogs from each other. It's great. But they actually just need a simple thing, which is they had to put things into production. And these things need to run to generate value, to generate money. And they don't really teach that in any of these online, massive online open courses that are out there that I know, because they will give you extremely good overview of how you theoretically do data science, maybe with a capstone or 2. But when it comes to, I have this piece of code and it needs an interface to the rest of my production environment, that they start to, well, it starts not to be so easy anymore. So what's the typical process that you do in these cases? So you start with a customer that has some requirements. And then usually you start doing exploration and then modeling, and you need data sources. And what you really need is that these models, they actually have to go into production. So the data scientists go to the data engineer or to the engineer or to whatever. And he says, I want to put this into production. And so the data engineer or whoever asks, okay, where is the data coming from? Oh, I get it by mail every Monday morning by this other department, and it's very good. It's the greatest data you will ever see. And the data engineer says, well, I really cannot do that if you want to put it into production. And I said, well, what about a USB stick? Is it going to help? And so they say, well, no, it's not going to help. So this is the first thing that breaks. All the data sources, or the majority of data sources, are not getting in automatically. And that's like the majority of the case we see are a problem of data sources which are not coming in automatically. So I'm doing a project at the Dutch railways, and they have a very cool model to detect when a train brake system is breaking down. And the data scientists were so happy about it because 1 to 3 weeks before a train would stop in the middle of nowhere because the brakes broke down, they could detect that the brakes needed maintenance. So this is like the perfect predictive maintenance model. And then, of course, you could ask, why are they calling us if they had this great model? And the thing is that they needed 2 weeks between data being produced by the train to data getting into the model. So the majority of this train would break down anyway because it didn't have the data in time, on time. And the second problem is we write crappy code as data scientists. So I remember at university when I was doing I don't remember if it was a master or PhD, my supervisor came to me with a Mathematica code that I wrote, and he says, don't you know that writing a variable KKK is like bad form for this American association that is also named KKK? And I looked into the eye and I said, well, you have a very good point about KK. I was using it for something else. And that was true for X, XX, triple X, Y. All the letters were just taken. And this crappy code, then you go to this data engineer and they said, I want to put it into production. And they look at you and they say, okay, so where are the documentations? Oh, I know it works. I wrote a paper about it. Well, but where's the code documented? No answers. And then they go there and they say, have you written unit tests? And you go like, unit what? Unit tests, like knowing that it's correct. But the paper has been published. And then they say, where's logging? And I say, well, I do a couple of print statements here and there to see the code is correct. And basically they have to throw the code away and to write it again from scratch. Because it's such a huge amount of work, take something written sloppily and then put it into production. Because as Niels was saying, once something is into production, you actually need to gather the feedback that is coming from your model and feed it back to the requirements. Because maybe your model is not working good. So always remember that almost everything should be measured and everything should be automated. So this guy at the Dutch railways were losing just for a single data source 300 hours per year just to email the data around that was going to feed the models. 300 hours per year for a single source. So how do we do that? Building a data product. So we start from the backlog. So we want to do something, and then we have to add data sources because it starts from there. From the input data, we do feature engineering and modeling or whatever, and we got our predictive model. And from our predictive model, we want to productionize it. And here I wrote data product and smart product because the first one would be like an API, and the second one would be something that the end user might use. And it doesn't have to always, you don't always need a smart product, but sometimes you do. And then either your data products and or your smart products are monitored and measured so that you can actually look how the model is doing. Once you know how the model is doing, you actually can to get a new backlog. And then you can ask yourself, do I need to add a new data source? Do I need to improve the model? Do I have to extend the API? Or what should I do here? And this is also something which seems very simple. It's just a stupid circle with some branches. But actually, to do this, And I slept too little tonight to remember if I talk about it in a sequence slide. But actually what you need here is that you need a measure for your model. You need a measure, and like in the Amazon case, sometimes accuracy is not the best measure you can choose. Or for the Dutch railway case, what should you optimize for? The times you take a train out of the system, or the times the thing breaks down. Because it has a cost to take the train out of the system, but it also you also have a cost when the train breaks down in the middle of nowhere. And so maybe optimization of just the accuracy is not the best one. You need to attach like an amount to each of your false positive and false negatives. And you need a business case for your true positive and true negatives. So having this metric, it's deceptively simple. And of course, in scikit-learn, you have all these different sort of metrics which are just ready for you there. But I see very little people that actually build a custom metrics with the costs of each miss forecast. Another thing which is very important, data contracts. What are these? You have your data products which you build in your data platform, and maybe you also have the data lake, and all different sort of data are flowing from internal business units to your data lake, and maybe from external data sources. And then you go to these guys here, or gals there, and you say you should use our model. It performs 20% better than the model that you're currently using, which maybe runs in your SQL database and is just a query with a couple of means and variances thrown up in there. And I said, this is very nice. How fresh is the data that you have here? And you say, well, we'll build this spectacular data pipelines. We get data which is maximum of 2 minutes old. And I said, okay, well, it seems very good. Let's start using it. Then these guys over here, which are not using your product, but they're feeding data to your data platform, they decide to do maintenance of the database. And for 3 days, you don't get any new data. So actually, the promise you made to this business unit here was actually false, because we're not yet used to think about SLAs, and I mean not everybody, to think about SLAs and contracts between the guys you're pulling data from and the guys you're offering products to. And if you don't have that in place, people actually will never use your model. Because even though it's 20% better, if it's out for a week, maybe they're losing millions. So that means that your data pipelines, your data contracts, your data whatever, should be pro-grade when you build a data product. Even though machine learning is maybe the heart, the data are the legs of your data products. So what skills are then needed from a data scientist perspective? What skills are needed? So this I took from a discussion on Hacker News a couple of months ago, and it's by no way it's like a scientific proof that it is true, but I think it resonates really a lot with the clients that we have. So here in this article, in the comments actually, in Hacker News, they claim that there are 2 groups of people. The one that have work experience building data products and strong software development skills, and those without. And the first group is in higher demand than ever. And I'm sure, I mean we are, but I'm sure almost all the sponsors that are here today, they are really, really interested in this first group. If you have experience, and if you have software development skills, you're in higher demand than ever. So the actual reason that I changed my job title a couple of years ago to shoe designer is that people wouldn't call me anymore on LinkedIn. And it actually worked until a lady from China asked me if I could design some shoes for their factory there. Luckily, I became chief science officer right after that. But anyway, it's really a thing. And I think everybody here that is a data scientist at some company, that you get called at least once a month or emailed or whatever if you're on LinkedIn, on average. The second group, on the other hand, is extremely crowded because everybody can write on their CV that they followed Andrew NG course on Coursera or somebody else on whatever. It's very easy to write that. And I said, well, I got a certification, blah, 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 blah. I never checked that. I don't know how many people actually do check that. But it's extremely easy to just say, well, I followed the course and I'm a data scientist now. And so that means that supply of the second group keeps growing while the demand is either flat or shrinking. Especially by executive getting burned by these so-called data scientists that are not able to participate in a workflow in which things end up in production. And so this is also actually the biggest differentiator we're seeing is that are you participating in building production quality systems? And this is not building production quality system, of course, because I don't think anybody expects from a data scientist to build a framework that Niels presented in the previous talk. But you have to participate to that, to be able to give code. Maybe it's not the perfect code, but it's easy for somebody to get in and tweak the performance a bit or change something without being scared that everything will break down. Versus being proficient in R or Python to hack together a prototype on your laptop with a small data set. And I'm seeing the same things happening here. We as Go-Data-Driven, we're definitely only interested in the profiles of the first group. And many, if not all of our clients are in the same position. Yes?
So would you attribute that to businesses not understanding the business value of machine learning, or is it the failed promise of machine learning to business that's actually causing this disparate group between what the data that you're showing us?
It will be probably a non-politically correct answer to your question. But I think there's two things. The first is that you have a lot of companies, like all the tech companies, internet-first companies, heavy R&D companies, that they have a very strict hiring process for every position, for every technical position in their department. And a lot of other companies, they either hire through just looking at the CV, talking to you a couple of times, but they do not have like a technical steps in their interview process to filter out these sort of things. So there are many companies when you just end up into HR, I mean speaking to somebody from HR, sorry, and of course it's very difficult for them to assess the technical skills that you need. This is on one side. And on the other side, many people, they still have to realize that this is what is needed to actually bring something into production. Because if you come from a business intelligence mindset, you need to write some SQL. And then as I showed you before, the enterprise data warehouse actually takes care of everything. Or the DBA takes care of all the data being there. And you're basically just writing some SQL, which could be optimized. But still it's just SQL. You're not expected to write tests, documentation, that sort of stuff. You have a much smaller surface where things could go wrong, I think. Does that answer your question? Okay, that means it's a no. Yeah.
Do you see there being some kind of chicken and the egg problem in machine learning, in which you only want people that have had experience building production systems and actually putting them on the air but you don't get that kind of experience unless you're hired into some place that's getting things into production.
Yes.
How do you solve it? For example, as a software developer with little experience in machine learning, I don't see how I could get into that, for example. How do you suppose to solve it for the industry as a whole, if that is a big problem? You don't have people that can deploy things.
So the good news is that you can learn, I mean, if you learn machine learning, and you know algebra, you know probability, you know statistics, you can also learn to code. I mean, not code on a software engineering level, but you could code enough to be proficient and to be to actually contribute to this production system. And I speak from experience, from somebody that was writing everything as KKK, and then actually can write. I can even write tests now. And of course, if you ask Niels, I'm still a terrible coder, but it's you can learn that. As for how you get a first position, I think especially the larger companies, they have much more space to actually give tracks in which they teach people these things. So you start from a very junior position. We work at several banks, and they have these tracks in which they have like these juniors, people, they come in, they know that they're junior, and they're actually mentored by somebody, or they work in the team where you actually can learn this stuff. The problem is, if your whole team is composed of these juniors people, then it becomes very difficult for the company itself. So if you don't have this like supervision by somebody that knows what he's doing, it's more difficult. But I don't have a definitive answer on how you could fix that. So as I just was saying, you need to write good software. That's just as easy as this. Writing good software already goes a long way into bringing something, which is a model that runs on your laptop, to put it into production. Because the good thing is that data engineers do exist, and they can actually help you with that if you didn't write a piece of junk. And of course now comes the I've told you so part, because a couple of, well, maybe 6 months ago, I wrote that a lot of data scientists approach the problem with a Kaggle-like mentality, delivering the best model in absolute terms. So this was tied to what I said before, that you sometimes need to optimize for something which is not accuracy, which is not the standard metric that scikit-learn delivers you. And I named that the Kaggle curse, even though it's not written here, because Kaggle, I think, really encourages you to deliver the best model in absolute terms without thinking of practicality. While in general, it's a model that combines practicality and accuracy, or whatever other metric you have, that gets implemented. As an example, the Netflix competition. 10 years ago, Netflix gave this $1 million prize to the team that would increase the accuracy of their recommendation by 10%. And I think they were pretty high already at that time, maybe 80–85%, and they won a model for 90–95% accuracy. And this team came out, I think they invented matrix factorization at the time to actually solve this particular problem. And they won the prize, and Netflix never implemented that because it was too slow for the volume of users and title that they had to actually be used into production.
They still use Python.
Yeah, and now of course 9 years went by and machines are cheaper, and a lot of things happened. Spark as well since 2008. That makes this much more feasible. So now using a matrix factorization algorithm is not, it's less taxing than it was back then. But you're right. And I think this was the last slide.